Good morning, good afternoon, and good evening, everyone. I hope all of you are doing fine. My name is Pooja, and on behalf of Special Cam, I'm very pleased to welcome you to our webinar entitled How AI is Helping Plastics Companies Remove Problem Ingredients and Reduce Costs. Our presenters for today's webinar is Austin Butke and Matthias Herman. Austin is a seasoned expert in the lubricants industry with a bachelor's in chemical engineering from Kansas State University and an MBA from the Quantic School of Business and Technology. He spent over 5 years at ExxonMobil Lubricants, where he held key commercial roles across both automotive and industrial sectors. Now at Citrine Informatics, Austin helps companies across the lubricants value chain build strategies to use artificial intelligence and machine learning to accelerate product development, drive innovation, and exceed their sustainability initiatives. With his unique blend of technical expertise and business acumen, he provides valuable insights on integrating advanced technologies into traditional workflows, making him a sought after speaker on the future of lubricants and digital transformation. Whereas Matthias is a solutions engineer at Citrine Informatics. He holds a BSc in chemistry from the University of Marburg, a master's degree from the University of Stuttgart, and a PhD in analytical chemistry from the Queen's University, where his research focused on developing microfluidic devices for automated mass spectrometry. He also brings industry experience as a lab team leader at BASF, where he coordinated high throughput screening projects for polymer formulations. His academic background combined with hands-on experience in both research and industry enables him to bridge the gap between scientific innovation and practical applications. Before we start the presentation, I would like to give you some tips on how to interact with us during the presentation. If you use your telephone and want to fully benefit from our event, we remind you that you need to dial the audio pin displayed in the attendee panel. During this presentation, you can use the questions tab at the bottom of your attendee panel for any audio or web issue you may face, or for any technical question or comment you want to address to our presenter. Your questions will be answered at the end of the Q&A session. If you don't receive an answer right away, you will be contacted shortly for individual help. Well, ladies and gentlemen, thank you very much for coming. I trust you will enjoy our session. Thank you, Austin and Matthias, for accepting to share with us your expertise today. And I let you start your presentation now.
As Pooja mentioned, everyone, my name is Austin. It's a pleasure to be here and talk to you all today about something that I'm very passionate about, and that is how artificial intelligence and machine learning is helping plastics company remove problem ingredients while also reducing costs. And we have a lot of good information that we're happy to share with you today, and I'm excited to dive into it. The first thing that I want to do to lead off the discussion today is just to give you some of the thoughts that I hear when talking to people in the industry. As being a member of the sales team, I'm in a fortunate position where I get to talk to a lot of companies around the world in different industries and really get to understand about what are their challenges and how a solution like Citrine can fit into those challenges. So here's just a few examples of things that seem to come up every single time that I talk to a company in this space. The number one thing I hear every single time I meet with someone in this space is the balance between maintaining performance while also improving sustainability. And we have a slide coming up here momentarily where I'll dive into this. The second one is the urgent need to reformulate and remove problem ingredients that include PFAS and phthalates. Kind of coinciding with that is this conversation around recycled plastics and how can we reformulate products to incorporate these recycled plastic materials, particularly in geographies like the EU where there is a lot of strict regulation being put into place. And then finally, I think this is something that I'm starting to increasingly hear more every day, just given the current macroeconomic uncertainty around the globe. It's this navigating this price volatility and supply chain disruptions. I think as we continue to see these challenges in the industry, the companies that are able to successfully navigate both price volatility and also the supply chain challenges are going to have a leg up on their competition. And we'll dive into how machine learning and specifically the Citrine platform can address some of those areas. So how does informatics help with some of these challenges? And first, I think it would be helpful, let's quickly define what informatics is. When I say informatics, really what I'm referring to is the data-driven approach to product development. And specifically, when I talk about data-driven approaches, we're talking about machine learning and artificial intelligence. And when we work with companies in this space, the first value area that they see when deploying machine learning in this space is around formulation excellence and particularly productivity and reducing development time. We work in a very high dimensional space. There is in a lot of the product development areas that we work in the plastic space, there are millions, billions of potential combinations that can be combined, and testing all of them takes a lot of time. There's a lot of iteration. And so what we found is using this machine learning driven approach, our clients are able to generally reduce the amount of experiments needed to hit those target properties by 50 to 80%. So what does that mean? That means reducing the development time, getting products to customers faster, but it also means reducing the resource consumption and allowing the product development teams at this company to move on, hit more projects, work on more complex areas. The second thing that ties into this is, as we all know, this space isn't just about formulation. It's not just about raw materials. It's very often that processing plays just as big a part as the raw materials that you're using. So being able to use a system that not only is going to consider the raw materials that you're using, but also the very complex processes that many of these companies have is very important. And so this combination of the formulation while also optimizing the process, ultimately what that leads to is getting answers to your customers quicker, getting better, higher performing markets higher performing products to the market in a fraction of the time. And so that leads nicely into Citrine and who we are. So if you're not familiar with Citrine Informatics, Citrine Informatics is a software as a service platform that provides artificial intelligence and machine learning tools to accelerate product development, optimize processing and production, and then ultimately increase sales. Citrine has been around for over a decade. We are specific to working with companies that use chemicals or materials in their products. And we like to say at Citrine, our machine learning is chemically and materially aware, and we were purpose-built for this industry. And so really what that means, and what I'd like to highlight, is we understand that in this industry, there is often limited data. And so having a platform that can understand the fundamentals of chemistry and material science to allow us to glean insights and be predictive using that small amount of data is absolutely imperative if you want to see results in this industry. The other thing that we've noticed over the last decade is the people that see the most value in these types of areas are the people doing the science. They are the scientists, the chemists, the formulators, the product developers, the researchers. And oftentimes, these people don't necessarily have the expertise in machine learning or artificial intelligence or coding or Python or programming. And so having a system that allows these people to make reusable machine learning assets through a very usable and forward-thinking user interface is absolutely critical. So we're going to dive into that today. So why AI? Like everyone talks about AI and machine learning, like specifically in this application, when we're talking about product development in the chemicals and materials space, like why is it important? Well, the reality is, and I alluded to this earlier, we work in a very high dimensional space. And what I mean by high dimensional is both on the raw materials. It's very common for when I'm having conversations with customers in this space, we're talking about dozens, hundreds, sometimes even thousands of potential raw materials that you have to consider. Then we're talking about another hundreds or thousands of processing parameters that need to be considered. And then at the end, we're often trying to optimize for dozens of parameters at a time. Things like performance, things like sustainability, things like cost, all of these things need to be considered. And when you mix all of these high parameter things together, ultimately what you come to realize is that the human brain is just simply not capable of considering all these things at once. And that's where machine learning comes in. And you'll notice a quote over here on the right. This is a quote that we get frequently here at Citrine, and I think it's conventional wisdom amongst the industry that when you're considering product development, there's better, there's faster, there's cheaper, there's more sustainable, and maybe you can optimize for one or two of those at a time, but it's almost impossible to do everything at once. There's always going to be some gives and takes, and what we've found is by using machine learning and allowing a system that can filter through all of this high dimensional parameters, we can optimize for all of them at once. So we'll talk about how that's done today. The other thing I want to hit real quick is this is not a pipe dream. This is not something that's coming later or going to be here in a few years. We've been around for a decade. We've been doing this for over a decade. We've worked with hundreds of companies. We have over 1,000 active users on our platform today. I want to highlight that this application, Materials Informatics, is something that we have been leading for over a decade, and our customers are seeing results today. And if we want to dive into a case study to illustrate one customer that has seen results, this is a case study that we did with one of the world's largest material science companies. They had a very big problem that they approached us with, and that problem is probably something that you all are familiar with on the call. They had PFAS in all of their pressure-sensitive adhesive product line, and they saw the writing on the wall. They saw the incoming regulatory demands, and they knew that they needed to get rid of this, or it would be a very expensive problem. But as many of you know, there's a reason that PFAS is used in a lot of these applications is because it's actually very good from a performance standpoint. And removing PFAS is not as simple as just taking out PFAS and replacing it in a 1-to-1 ratio. That's often not how it works. And so navigating this very, very, very complex formulation space that includes a number of different variables, both on the raw materials while also processing conditions, is a very challenging product. And so what this customer did is they started in the first month by training the internal teams on using the Citrine platform and getting to autonomously. And you'll notice here that this happened in a month. This didn't take 6 months or a year. These scientists didn't have to go learn how to code or become an expert in data scientists. A lot of that is easily done through the UI, as Matthias will show in the demonstration. By month 3, these scientists had screened millions of formulations and narrowed it down to 30 potential candidate formulations. By month 4, they had already identified a potential breakthrough candidate for their formulation. And then by month 6, they had built upon this success. This wasn't just a situation where we have a problem, we're going to fix the problem, and then we have no need for this anymore. They realized this is a problem that we can scale across other applications in our business. That's one of the benefits of machine learning, is once you have these assets built, you can deploy them across other areas of the business. And this customer identified that and scaled that very quickly. And so ultimately what this led for the customer is they anticipated in their typical R&D workflow, this type of project would have taken roughly 5 years for completion. By using the Citrine platform and this machine learning driven approach, they were actually able to save over 2 years of work. And so the last thing I want to quickly mention before I pass it over to Matthias so he can go through a demo is something that I want to highlight very quickly. It's the competitive advantage is no longer just doing something. And I think that was the case 5 years ago. 5 years ago, if you were in this space and you were thinking about or dipping your toes into AI and machine learning, you probably had a competitive advantage at that time. But it's almost 2026. I speak to dozens of companies every single week. I can tell you that every single company in the chemicals and materials and plastic space is thinking about how to use these technologies within their workflow. And so the competitive advantage is no longer doing something. The competitive advantage is going to be execution and scale. The companies who execute the best and are able to scale it across their organization in the most efficient manner are going to be the ones that win. And I think we'll soon come to see this in the coming years as this technology begins to be adopted across the industry. So that's it for my section of the presentation. At this point, I'm going to pass it over to Matthias so that he can jump into a live demonstration of the Citrine platform and we can show you firsthand just how some of this work is done. So Matthias, over to you.
Thanks, Austin. I'm excited to show you now on the platform live how that could look like. So what you can see here is the Citrine platform, and we prepared here a demonstration that shows you on how we could, for example, optimize a PVC formulation while achieving different targets. Once, we want to optimize the performance, such as the mechanical stability, at the same time minimize the cost, but also minimize the environmental impact. And while doing all that, also fulfill certain regulatory requirements, such as not using any phthalates in new formulations. And all that is done on the Citrine platform in a workflow that is shown here. We have a 4-step workflow starting with the training data, which is basically data that you have in the lab currently. That is data from experiments that you performed in the past. Maybe those experiments contain some problematic ingredients that you're not allowed to use anymore, but we can use that data to build an AI model. This is the second step. And then with that AI model, we are then setting some restrictions. This is done in the search space, which is the third step here. And then at the end, with the model and within those restrictions that we are setting, the platform gives you a list of possible formulations that are most likely to hit different target properties. As I mentioned, those could be things that are competing, like the performance, while also minimizing the cost. And I will show you each of those steps in more detail and how the Citrine platform can support you in accelerating that process of getting faster two candidates or two formulations that fulfill your goals. Let's start with the training set and with your data. So the basis to build a machine learning model is the data that you often have already in the lab. Within the last months or years, you have already collected maybe some experiments on some PVC formulations, but those are using some ingredients that you cannot use in the future anymore. We can still use that knowledge that is in that data. We upload that data simply by dragging and dropping an Excel file onto the platform. And what we can do at the beginning is we can explore the data. For example, one of the properties that was measured in the past is the elongation, or not the elongation, it's the tensile strength to elongate a material by 100%. And maybe I would like to develop a new material which has a value of at least 15 megapascals. So I can look in my historic experiments, which are plotted here, and check how does one of those formulations look like. By opening that, I get here a graphical representation of the material and its history. What I mean by that is basically any information correlated to that particular experiment is put together here. We have here, for example, the final PVC formulation with several measured properties, mechanical properties, but also quantifying the environmental impact. And then if we go to the left side, we can see all the different ingredients and how much of those ingredients are mixed together to get to that particular formulation or product. Looking deeper, we can, for example, also look at one of those phthalates that are used as a plasticizer and add more information about those ingredients in here. Here we have, for example, cost information, the density. If there is a chemical structure, also that can be added. This is information that can be simply got from technical data sheets or safety data sheets. And this basically is the basis for building a machine learning model. Putting all the relevant information together, tying it together, providing context, and then utilize that to build a machine learning model. Before that, we can explore a little bit more in detail what the data looks like, how it's correlated. For example, I know that we've been using one phthalate quite often, which is the diisononyl phthalate. So we can look in what formulations has then been used and what is the impact of those on some other properties. So for example, I can see here in that graph, when I'm increasing the amount of that phthalate, it tends to also increase the elongation at break, but at one point it actually has a negative impact on the elongation. And overall, the tensile strength is decreasing when I'm adding more of that particular phthalate. And this is a way to kind of explore a little bit more in detail your current data in, let's say, a manual way. One other interesting aspect here could be, for example, also the toxicity. Even though that phthalate is toxic, it seems like by increasing the amount of that phthalate, the toxicity is actually decreasing. And what's happening here is basically that by decreasing the amount or decreasing the amount here to the left side, we are actually adding some other alternative plasticizers into that formulation, which at the end make it overall more toxic. So optimizing a formulation is tricky. Austin mentioned it before, there is a lot of inputs, there is a lot of things to be optimized, and doing that in such a manual way can be tedious, challenging, and that's why AI comes into play and can support us here. Let me show you how we can now utilize AI in order to interpret the data and find suitable next best experiments. This is done by building an AI model. Building an AI model might seem complicated, but let me show you this can be done with a few clicks. You click a few times, and what the platform is doing is it's utilizing the data that you provided and suggests an AI model. The AI model is here shown in a graphical way. No coding is required. You do not need to be an AI expert. And to quickly explain what's shown here is that we start with the training data that I just showed you, your data from previous experiments. And then based on that data, we are extracting information. I showed you earlier of that phthalate, that chemical structure. From that chemical structure, we are extracting, for example, information such as the number of atoms, the number of acid groups, and those are then used as an input for machine learning models. Other information that is extracted are the amount of different ingredients, the type of ingredients, and so on, which are then used for those machine learning models here at the bottom. Now, This is just the suggested model by the platform, looking at the data. Now, I, as a formulator, know, for example, that the elongation at break is actually closely tied to the 100% modulus and the tensile strength. So what I would like to do is I would like to predict the elongation at break with those two as an input. I can here now make modifications on the model. This can be done by dragging and dropping those nodes in here and making adjustments, or to make it even simpler, we can use an assistant called Catalyst here. We can communicate with Catalyst simply by giving it a prompt or an instruction. In this case, make a separate machine learning model for the elongation at break that uses the tensile strength and the 100% modulus. Citrine recognizes that this is an instruction to make a change to the model. I accept it. And what happens is that it updates the model according to that prompt. Now I have the elongation at break here as a separate model, which uses those as an input. And this capability is quite interesting if you are trying, for example, to reduce the amount of complicated experiments. You might have a weathering test that takes a few weeks to be performed, but at the same time, you have also a short-term test in the lab that you're utilizing as a proxy. So we could tie those together and see how those are correlated so that at the end, you do not need to perform as many of those time-consuming, complicated experiments. There is a lot of flexibility, and we want the platform to be used directly by the formulator who has the experience, who can implement the knowledge onto the platform like that. Once we build the model, we go to train and validate, start training, and about 10 to 18 minutes, the model will be trained and we can utilize it. Let me show you a model that we trained already and how the output could look like. The model is not a black box. We want to provide insights, and we want the user to really understand how the model is actually predicting those properties. What correlations is it picking up on? And this is what we can do here in the Evaluate tab. We have here the different models that we created before. And first of all, we get an idea on how well the model is actually performing. How good are the different predictions? For example, let's dive deeper into the 100% modulus. That graph here shows us how good the predictions are compared to the actual value. It performs a cross-validation. Long story short, the closer the purple points are to the green line, the better the model is. And then we can dive deeper and try to understand what inputs are actually used to make a prediction for the 100% modulus. And these are those plots here. Those show us what impact or what inputs having an impact on the property to be predicted and how are those correlated. What I found, for example, interesting is the amount of plasticizer. What we can see here is with increasing amount of plasticizer, if that has a positive impact above 0 on the 100% modulus or a negative impact, or if it doesn't have an impact at all, remaining it at 0. And what we can see here is that there is a bunch of experiments where at a higher concentration of plasticizer, it doesn't seem to impact this as much. But there is a spot at 0.25 where it seems to could have a high impact on it, but also slightly negative. And we can then dive deeper. We can look at the experiments that this is based on, and then try to understand better on how the platform is actually making those predictions and providing or getting further insights. So overall, it is not a black box. We want to make it accessible for the user, for the scientists to really understand how are those correlations actually built. Now we have a model, and we would like to get some target properties achieved at the end. As I mentioned at the beginning, there's multiple ones like a certain tensile strength, a minimal environmental impact, also minimizing the cost. And now we can use the model to find those ideal experiments. But before that, we need to, let's say, tame the model a little bit, because as of now, the model could explore all different kinds of combinations of ingredients in different amounts, and we are restricting that in the search space. One thing that we could, for example, restrict is what ingredients to use. I showed you at the beginning, one of the data points that was performing quite well was containing a phthalate as a plasticizer. Now, let's say next year we need to find an alternative that does not use any phthalates, but we can still use the data that contains phthalates to build a model and look for correlations. In order to tell the platform now to not use any phthalates in the suggested formulations, we can go to the search space, look for any ingredients that are labeled as phthalates, and force the platform to exclude those. So here you can see we excluded all phthalates and do not allow those anymore. Also, what you can set up here is how much to use of different types of ingredients. For example, we're adding a stabilizer, and we do not want the platform to suggest us anything that uses 10, 20% of a stabilizer, even though if the model would assume that it could perform well, it just is not reasonable for us, and then we can set those restrictions. We can also simplify a formulation and forcing the platform to only use a certain amount of ingredients, and so on. This is all done in the search space. And so you can basically create different search spaces, maybe for different geographical regions. Maybe in the EU, we have a few ingredients that are allowed that are not allowed in North America or Asia. So we can add a new search space where we would restrict different ingredients for that geographical region. And then based on that search space, with the AI model, we can then go ahead and create what we call candidates. Those are formulations that are fulfilling certain target properties that we would like to achieve. In this case, we are optimizing for some mechanical properties like the tensile strength, also for the elongation at break. At the same time, we would like to minimize the environmental impact and the toxicity, while also minimizing the price, and at the same time not including any phthalates. So you can see there are quite a few of questions that we are asking, and it becomes quite quickly a quite complicated problem. But the nice thing is, with the AI assistance of the platform, we can now provide all those goals and see what candidates are suggested. And by candidates, I mean suggested formulations that are most likely to hit those properties. So we get a list, in this case, 100 different candidates that could potentially achieve all those target properties. And now we can explore those a little bit more in detail and try to find a good balance between all of those. Here you can see that the predicted outcome of the elongation at break and the cost are plotted against each other. We would like to minimize the cost and maximize the elongation. So looking at those, it seems like a no-brainer. We should take this candidate here. Let's have a closer look at that one and how that result looks like. When we open that particular candidate, what we will get is a recipe. This is basically something you can take directly into the lab and test. See if it's working or not. You have the ingredients, you have the amount of the ingredients, you can review it, and if you say, this one looks promising, just save it, take it into the lab, test it, and check if the predicted outcomes are actually right. You can see here the platform gives you a predicted outcome for those properties that we're trying to achieve. And not only that, it also gives you an uncertainty range. You remember earlier when I showed you the model performances, how accurate those are? Those are also represented here. It's quite common that some models are performing better, others not performing as well. Really depends on the data, on how much data you're providing, but it is transparent with you. You see directly, okay, here it makes a prediction, but it's not as accurate, but it's within my target range. And what will happen is the more experiments you perform, the more data you provide, the more of your knowledge you're integrating into the platform, the smaller the uncertainty bars become. And so we could take that one, go into the lab and test it, but let's go back and check actually what is about the toxicity, because this is also one of the properties that we would like to optimize. So let's go here and say we plot that now also against the toxicity. And what we can see here now is that that one candidate is actually not performing as well regarding the toxicity. We have that now here on the y-axis. It has a quite high toxicity, even though the other ones were performing well. So maybe we need to find something with a trade-off, a compromise between all of those. Looking at that graph, it might be any of those here in the middle. Still a decent elongation, lower toxicity, and in blue I have highlighted the ones that are below $2.7 per kilo. So maybe one of those here in the middle might be a better one. And you can see already this is the way how you can explore those candidates. And again, utilize your knowledge, your experience on picking suitable good candidates. And you can use the platform to find candidates, what we call safe bets, basically optimizing for the percentages of some ingredients and really trying to fine tune it, and something where you know it's going to work or it's been working in the past, but really finding the optimum ratio. But you can also use it to find what we call exploratory suggestions. So something that might seem a little bit more unconventional, something what you were maybe not thinking about at the beginning. And it's a nice way to remove biases, only because we've been formulating certain ingredients or certain formulations in a particular way. It might be that the platform in the AI model is suggesting you something that seems a little bit off or not what you would usually try. And then you can say, actually, why shouldn't it work? Let's give it a try. I also pinned this one, go into the lab and test it. And more than often, you might be surprised, more than expected, you might be surprised how often those unconventional exploratory results could work. And with that, you would then go into the lab, test a few of those suggested formulations, and then see how well the predictions were. It might be that you find directly a good result and a candidate that fulfills your requirements. It might be that it's off. But that's also okay. What happens then is that we would take that result, feed it back in here into the training set, and then retrain the model. The more data we have, the more we test, the better the model becomes. We would then create a new set of candidates and get closer to those desired properties. So this is basically the workflow of the Citrine platform. We start with some data that you have uploaded simply by dragging and dropping it onto the platform. Build an AI model without any coding, any AI experience. You can create a model here. Then set up a search space, communicating what restrictions we have, telling the platform what ingredients to use, how much to use it, if there are certain process windows we need to be within. And then we perform a multi-objective optimization, basically having multiple goals, trying to optimize for those at the same time, and then get a list of candidates that can be tested. And with that, I hand over back to Austin.
Thank you, Matthias. Before we wrap up today, I very quickly want to just walk through a couple of tips, some best practices that we've noticed from the last decade of leading this space. And the first tip that I want to offer is one of the main things that I hear from companies before they get started is they think either they don't have enough data and or their data is too unstructured. It's all over the place. It's in different formats. And therefore, because we don't have enough data or our data is all over the place, we can't get started using AI. That's something I hear very frequently. I'm here to tell you that I've talked with hundreds of companies at my time at Citrine. Every single company is facing this problem. Every single company fears that they have too little of data and data is all over the place. And what I can tell you is we have seen success with every single type of data that you can throw at us. We have seen success with zero data. We've seen success with hundreds of data points. We've seen success with very structured digital databases. We've even had customers, ship us handwritten lab notebooks to get started. What we find is that the majority of the projects that we get started with fall into a category that you'll see right here, which is a typical Excel spreadsheet. Typically, this includes certainly less than 100 data points. Usually, we're working in the 20 to 30 data point landscape for a particular project, and it exists in some form of tabular spreadsheet, like an Excel spreadsheet. And this is exactly what we've designed the Citrine platform to do. We understand that this is something that we face in this industry, and so we make it very flexible, and we want to meet you where you're at on your data landscape and show you results. So I would just say that if you have concerns over your data landscape and you think that that is hindering you from getting started with AI in the space, let's have a conversation, reach out to us, and we can have a discussion, because I promise you we've seen it all. The second thing that I hear all of the time is companies that say, we know we want to get started with AI. We know AI and machine learning is beneficial to us, but before we can do any of that, we need to get all of our data together. We need to get it cleaned up. We need to structure it. What we have found is that this approach often fails, and it fails for a variety of reasons. But one thing that we've noticed for companies that take this approach is that scientists like doing science. Scientists don't necessarily like entering data. And we have found that when you try to boil the ocean and condense every single data point that you've ever captured in your company and get it all into a consistent format, there's often a lack of motivation, because nobody can see the value. Like, what are we doing this for? I've heard that from so many scientists that say, we're manually entering all this data, we're getting all this data cleaned up, but I'm not really sure what the value of it is. What we have found is taking the inverse approach. We would, what we call it is agile bootstrap approach. And the tagline that we like to always say at Citrine is data utilization drives data harmonization. And by starting with a project or 2 or 3 in mind, but these are specific objectives that you're trying to achieve, and then working backward, find the relevant data for that project. So instead of boiling the ocean for every single data point you've ever collected and then seeing what happens, start with a few projects in mind, work backwards, find the data that's relevant for those projects, prove success, and then let those success points be the carrot that encourages the users to say, this is the value. Okay, I see the value. I understand why it's important to collect this data and to consider it. So data utilization drives data harmonization. I can't overemphasize this enough that it is not necessary to get all of your data in order before you see results with AI. If you want to learn more about our experience in the plastics industry, or just our best practices and thoughts on data and AI in the industry, I'd encourage you just to scan this QR code you see over on the right here, or go to our website at citrine.io. We have a lot of really great resources, such as case studies, previous webinars, white papers, blogs. There's a little bit of everything depending on what you're looking for. So I highly encourage you to take a look there. And in summary, what we've discussed today is artificial intelligence and machine learning can help you reformulate your products faster, meet your sustainability goals, while also maintaining that product performance that your customers expect. The Citrine platform is very easy to adopt. We have designed it for the data limited environment, and we've also designed it for scientists and product experts, not necessarily experts in machine learning. And we've been doing this for a long time. Our team brings over a decade of experience in implementing AI for companies like yours. So if you have questions on whether or not you think that this approach is right for your company, I would encourage you to please reach out to somebody at Citrine, go to our website, request a demo, and get in touch with someone at Citrine, and we can have a one-on-one conversation to really figure out where this fits within your company's landscape. So I want to thank you all again for joining. It's been a pleasure. And at this time, Matthias and I will be here to answer any questions that you all have. Thank you.
Thank you, Austin and Matthias, for all this valuable material and this great presentation. We already received chat questions from our audience today. Thank you, and please be informed that you can still share your questions for our experts. I will start with covering the ones about the presentation. Also, please be assured that the webinar today is recorded. We will send out the link to recording and the presentation after the live session, and we will also make it available on demand for you. And now I would like our experts to answer the first question with us, which is, what is the difference or advantage of AI methods compared to DOE?
That is a great question that I'm happy to answer. I will say that is probably one of the most frequent questions that I get every single day. So first, definition of DOE, I'm sure most of you are familiar, stands for design of experiments. It's a very common way of approaching product development in the industry. Let me state that design of experiment is very valuable. There's a reason that people have been using it for decades. It is very valuable in specific use cases. Where I see AI and machine learning and materials informatics, it is the next iteration of DOE. It's the next iteration of design of experiment. And how it really differentiates is design of experiment is very helpful if you want to explore relationships between just a few variables. So maybe you know that I want to keep these 3 things static, and maybe I want to manipulate these 1 or 2 variables to see how that affects my outputs. If you are working in that small parameter space, design of experiment can offer benefit in that area. Where we see design of experiment fall short, and where AI and machine learning really shows more significant tangible benefits, is in that higher dimensional space. So maybe you have several different potential ingredients or raw materials, you have several different processing conditions, you're not exactly sure exactly which variables you need to manipulate. That setting up a design of experiment in that parameter space is going to be very, very, very tedious, and in often case it will just be impossible. It will be feasibly impossible for you to explore and run all of the experiments necessary to get a beneficial design of experiment. And so machine learning and AI is actually very, very good at looking through that high dimensional space and learning from all of your available data, both your historical data and also new data that you capture. So the AI is very good at uncovering those complex non-linear relationships that DOE can't capture. So very short summary, DOA is helpful if you are exploring within known boundaries, but once you get outside of those known boundaries, AI and machine learning are going to help you predict and optimize beyond them. Great question.
Thank you for answering that so nicely, Austin. Let's take up the next question, which is, what is the typical size of the database you need to get a good model?
Also a great question. I can take that one. So a good size to get started with Citrine and build a model are around 20 to 30 data points. This is what we would consider a good minimum amount of data. And when I talk about a data point, I mean one experiment where we have some information about the ingredients, where we have information about the process parameters and the final results. If you're changing any of those, if you have another ingredient, another amount of an ingredient, then that would be already considered the second data point. And so we have seen that this is like a good amount that most people have already available to build a model. And then we can get started from that. And as shown in the demonstration, goal would be then to test a few of those suggested formulations that the platform gives you, and then extend the database, improve the model with that, and then get better and better results. So long story short, 20, 30 data points is a good starting point for a good model.
Just to add on one more thing to what Matthias just said, one way that I like to think about the modeling approach on our platform is our machine learning learns in 3 ways. It learns from historical data, which Matthias just talked about. If you have 20 to 30 data points, that's an amazing starting point. It learns from your domain knowledge that you can build into the machine learning that Matthias showed in the demonstration. And the third way that our machine learning works is through future experimental iteration. So experiments that you run in the future. What we have found and what many other experts in the industry have found is that third method, that future data creation, is often the most important to building a predictive model. So it's very common for us to work with clients with very little data. We even have clients come to us with 0 data, say we've never ran an experiment in this area before. But if you have that ability to experimentally iterate, if you have the ability to go to the lab and collect new data points, oftentimes that's much more impactful than starting with many data points. So the amount of data that you start with is oftentimes not nearly important. You'll hear a lot of people at Citrine talk about, we don't really care what data you have. If you have a good set of data, that's great, but it's not necessary.
Interesting. That gives us a lot of insight. Now let's take up the next question, which is, does the platform come pre-populated with data and trained models for the use cases just showed?
So connecting it with the previous question, as we said, a low amount of data is sufficient to get started. And that's why we usually provide the platform without any data. First of all, any data that you're uploading is staying within your own private instance. So we're not using any data that you're uploading, that other customers are uploading for using or for training models that you have access to or other people have access to. We really take it serious to make sure that the data is not shared across different customers. That's not going to happen. We know that it's really sensible data, really important data, and so that always stays within your instance. And because of that, there is no exchange of the data. And it is not really necessary to have some pre-populated data in order to get good models. We said it, 20, 30 data points is a good starting point. This is usually something that a customer can provide. If not, then Citrine can also guide you in finding the first experiments to get an initial good model. And we also want to make sure that we remove any biases. And the best way to get a good model is with highly relevant data that we can trust, and this is usually data that you have. And that's why we recommend to just use your data and start with your data to build the model.
And then in that note, talking about pre-trained models, we are Citrine. What we've built our platform to do is to give you a very good starting point with a model based on the format of your data. And so as you saw in the demonstration that Matthias led, once you have the data on the platform, you can create a machine learning model with about, I think it's 2 clicks of a button. So with 2 clicks of a button, you can have a starting machine learning model, and then to train that model takes roughly 5 to 15 minutes. So we again, going back to what I mentioned at the earlier presentation, we understand that the majority of the people using our platform don't have the expertise to build their own machine learning models in Python. We want to lower the barrier to entry so that anybody, regardless of their experience, can get started building models using their data and then refine and improve upon those, as Matthias showed.
That's great to know. I'm sure our audience finds this very useful. I'll take up the next question, which is how much does the software cost?
That is a great question. That's probably the second most common question that I get behind how much data do you need? What I would say is we price our software and our services dependent on many factors, such as company size, industry, location, etc. So it's very hard for me to give an exact amount without knowing who I'm talking to. What I would say is if you feel that Citrine Informatics and the Citrine platform would be a useful tool for your organization, what I would recommend that you do is you can follow the link on the screen, or you can just go to citrine.io. That will take you to our website, where you can, in the top right corner, there will be a button to request a demo. If you submit the request a demo button, what that will do is send a notification to one of our sales experts like myself. We will get in touch with you and we can have a very tailored discussion to understand more about you, your company, your specific needs, and then from there we can get you an estimated price ballpark. So if you fall into one of those camps and you suspect that this would be valuable for your organization, I highly recommend that you request a demo on our website, and we will be in touch.
Thank you for answering that, Austin. Next question is regarding IP. Do you take any IP in the materials developed using Citrine?
The answer to that question is no. We are a software company, so we provide the tools, the knowledge, and the expertise to allow you and your organization to reap the benefits of machine learning. But we have no interest in your IP. So any IP that you generate as using our platform is yours and yours alone. We own the software, you own the data and the IP.
How do you keep your data safe?
I can take this. The short answer is that we have a very robust information security department here at Citrine. We follow all the necessary protocols. We go through an annual audit for ISO 27001. And for those of you familiar with the software industry, know that is usually the gold standard for software security. We understand that we are asking our customers to, many cases, upload their most sensitive information and intellectual property into our software platform, and we do not take that lightly. We know that if there were any chances of that information being released or shared amongst the public or shared with competitors, that we would not be in business very long, and we do not take that lightly. So in short, we take information security extraordinarily seriously. If you want more information on some of our practices, you can go to our website. At the very bottom of our website, you'll see a link to our Trust Center. Our Trust Center is where we have all of our diagnostics and ongoing information security protocols. And if you want to have more in-depth discussions, we're more than happy to connect you with one of our engineers to discuss some of the specifics. But in short, we understand that we would not exist as a company if we did not keep your information safe.
Thank you so much, Austin and Matthias, for answering all these questions. We have received many chat questions today. We would like to remind you that if you don't receive an answer right away, you will be contacted shortly for individual help. We will keep this session open for another 2 minutes so that you can still ask your questions by chat. And before we close it, Austin, I would like to invite you to deliver a few final words for our audience.
Yeah, thank you everyone for taking time out of your day, whether it's your afternoon, your morning. We really appreciate you joining Matthias and I so we could talk about the work we're doing here at Citrine Informatics. If you want to learn more, if you want to have a one-on-one discussion, again, we have a lot of information at our website, citrine.io, citrine.io. You can see a lot of our old webinars, blogs, case studies, white papers, and then again, if you'd like to have a tailored discussion to see where Citrine could fit into your organization, I highly recommend submitting a demo so one of our sales experts can get in touch. So thank you very much for your time, your engagement, your questions, and I hope everyone has a great rest of their day.
Thank you again, Austin, Matthias, and entire Citrine team for this great webinar. And thank you all for your attendance and engagement today. Please take a few minutes to answer to our survey in order to help us improve our future events. We wish you a very pleasant day. Stay safe and goodbye for now.